Here we are showcasing the dry run for our project. Our project deals with concatenation or stacking of the contemporary image classification techniques such as ResNet, GoogleNet, and BGG16, and thereby producing a hybrid model that thus utilizes the best from all these models. So getting into the ResNet model, first is the importing step where we input necessary libraries needed, and this includes OS and paths for accessing images, NumPy for array manipulation, and CV2 for image preprocessing. And then is the next step, which is importing images from the data set and specifying labels such as cancer and non-cancerous ones. Over here. Then comes the pre-processing step. This step is where every image goes through certain steps such as enhancing colors, then converting RGB and resizing. And next step is the augmentation step. So in augmentation step, we are performing augmentation or enhancements such as rotation, zooming, shifting, flipping, shear, height, width, and other things so that they are enhanced accordingly. And this step gets followed by specification of layers using the Keras library. And these layers are pooling, flattening, and drop-off layers. Finally, we are training the model to perform classification in the testing phase. One thing to be noted is that during the training and testing phase, series of operations such as hyperparameter tuning, adjusting the epochs, having an eye on the loss rate, all are mandatory to avoid overfitting and underfitting issue. And here is the graph for model accuracy and loss rate. In ResNet, it can be found that even after 25 epochs, accuracy in validation is lesser than accuracy in training phase, and also loss in validation phase is greater than in the training phase. And finally, the output. And finally, here is the output for the ResNet model. The output has been predicted as non-cancerous one using oral histopathology image. Here comes our second model, that is GoogleNet. So just like our previous model, in GoogleNet we are importing necessary libraries as part of our first step. Then we are labeling the data frame for the classification purpose. Just like ResNet, we are performing image pre-processing and augmentation before training and testing. Now we will get into the architecture of GoogleNet. So this step involves building up of layers like convolution, pooling, flattening, and dropout, which has been imported from the Keras libraries. And so we can see that we can use any number of layers as a part of enhancement. And here we have exploited the layers into 6 stages as per our requirement. So now getting into the accuracy and loss rate. So we can see that just like our previous model, even after so many epochs, that is 25, model accuracy is poor in validation when compared to training. and also the model loss has not decreased in the validation phase. So finally, the result. Here comes the result. The output has been predicted as cancerous one using the histopathology image. You can see it here. It has been predicted as cancer. Then is the VGG16 model. Like previous model, series of steps follows, like importing packages and libraries, image pre-processing, training, and testing. Now we shall look into the accuracy and loss function. Here also we can see that model accuracy is high in validation when compared to the model training. Model loss is lower in validation when compared to the model training. But it must be noted that the margin between model accuracy and model loss between training and validation is a matter of thin line. And then we shall look into the output. Finally, here comes the output for VGG16. The classification has been confirmed as cancerous 1, so which has been labeled on the top left corner of the image. So you can see it over here. Concatenated model. Here comes the concatenated model, which utilizes the models that has been trained and tested before to perform classification of cancer versus non-cancer data set. Here we're going to use neural network as our intermediate models. So we require importing of libraries and packages from Keras. Then we should also be using the stacking functionality provided by the scikit-learn. So we shall utilize the wrapper provided by the Keras also. Now we shall look into the defined functions. Now we are looking into the load all models function. This can now load all the models, that is the saved submodels, and now train a meta learner that shall best combine all the predictions from the submodels and ideally perform better than any single submodel. Then we have stacked all the submodels. Then we now call this function to load our previously saved 3 submodels, that is the GoogleNet, ResNet and the VGG16. Then we shall evaluate the accuracy of each of the submodels and also look into the accuracy of the concatenated model as well. We can see that the best performing model is the concatenated model with an overall accuracy of 0.9667, which is approximately 96.67%, followed by the VGG16 model. Now we shall look into the confusion matrix of the concatenated model. So it shall be noted that the true positive rate is 119 and the true negative rate is 113. So these are quite high when compared to the previously tested models such as ResNet, GoogleNet and the VGG16. So it can also be noted that since the true positive and the true negative are high, the accuracy shall also be high. This is a graph plotted between the true positive and the false positive rate taken along the y-axis and the x-axis, and this has been plotted for the 3 contemporary models VGG16, ResNet and GoogleNet, and the concatenated model also. So it can be observed the model with the high for true positive rate is the concatenated model, followed by the model, the contemporary model VGG16. Here is the output for the concatenated model. For the histopathology image used, the output has been predicted as cancerous. So finally, it can be concluded that the concatenated model works better than all the contemporary models such as VGG16 ResNet, and GoogleNet.